put in the previous about the elliptic curve. Okay, so the elliptic curve is represented by this function, by this cubic function. So y squared plus a1 xy plus a3y equal to x cubed plus a2 x squared plus a4x plus a6. This is the representation of the elliptic curve, which is a function of x and y equal to 0. Okay, this is just to refresh. We said that if this function, if the partial of this function with respect to x and the partial is equal to the partial with respect to y, and that is equal to 0, that means that the elliptic curve, AC, elliptic curve, is singular or has singularity. Right? In the other hand, if this is not, let's say this is delta, it's not equal to 0, then that implies the elliptic curve is non-singular. So this is establish the discriminant. It's established by the quantity b equal to negative 4 a cube c plus a squared b squared plus 18abc minus 4b cubed minus 27c squared. Now, if a is equal to 0, so these terms are gone, and we have only this, minus 4b cubed minus 27c squared. If d is different than 0, that means my elliptic curve has non-repeated zeros. And this is very important for the application that we wanted to do, because for the application we want to use this security and cloud computing or wireless and things like that. So it is very important to don't have singularity and to don't have repeated zeros, and we must test for this. Now I wanted to put elliptic curve over the finite field FQ. So we say like, okay, let's try to understand what is this. Elliptic curve over the finite field P. P is a prime number. We understand that f of Q is an extension field of f of P. So it means that we have Q equal P E elements. Okay, so what I will find is the set of solutions of the curve, which is represented by f of x and y equal to 0, which is the cubic curve, which is our elliptic curve, and we wanted to find the set of points on P, the rational points. Means that we have x and y, where x and y are elements of the finite field P. F of x and y is equal to 0. Okay? Alright? Okay. Q is a rational numbers, P is the prime numbers. Okay? Now, okay. Let's go to put the example. let's pick up a cubic curve. This is a nice example, okay? This is in the form of ABC. We first of all test for singularity. Okay, well, d has to be different than 0. We know that d is equal to negative 4b cubed minus 27c squared. So we have this and these values, so it's 1 and 1, 1 and 1, so it's going to be some negative number. So yes, that's true. This is different than 0. So that means we have non-repeated zeros, and non-singularity, and the elliptic curve is non-singular. Okay, that's good. That's good. Now let's say that I wanted to find this set of rational points for this in the finite field of p equal to 5. Okay? So say finite field 5. 5 is a prime number, right? Okay, so how do I do that? Okay, perfect. This is the good part. The good part. Okay. If y squared equal to x cubed, y squared equal to x cubed plus x plus 1 in the finite field of 5, that means that my set of solutions, x and y are elements of the finite field of 5. Okay? I will recall the modular math, the mod 5. Okay, so I have x equals 0, 1, 2, 3, and 4. All these numbers, all these integers are elements of the finite field of 5. Okay? So what I will do, just to put this together, I will create a table. 0, 1, 2, 3, 4, 0, 1, 2, 3, 4 for this finite field. And I will use this operator. So this is 0 times this, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, and then is 1, 2, 3, 4, then is 2, this is 4, and then 2 times 3 is 6, but 6 in mod 5, it's going to be equal to 1. 2 times 4 is 8, but 8 in mod 5 is equal to 3. And then 3 times 1 is 3, 3 times 2 is 6, is equal to 1. 3 times 3 is 9, which is equal to 4. 3 times 12 is equal to 2. And then 4, then 3, and then 12, but 12 is equal to 2. And 16 is equal to 4. 16 is equal to 1. Okay? All right. All these numbers, all these are under this finite field of 5. So what I wanted to do, just to recall these, I will use these numbers, put it back into the equation, and I will get my set of rational numbers. So okay, I say the equation is y squared equal x cubed plus x plus 1. So if I give y squared for 0 to the cube plus 0 plus 1 is equal to 1. So that implies y is equal to plus and minus square root of 1, which is 1. Okay? So there exists the first point. The first point is 0, comma, plus and minus 1. That's the first point. Now the second one. Second one is y squared equal to 1 to the cube plus 1 plus 1, and this is equal to 3, right? So y is equal to plus and minus square root of 3. But this is not a rational number. This is irrational. So I will discharge this number. Okay? Well, I test the second one, which is 2. So I put 2 to the cube plus 2 plus 1. And that gonna give me 6, 7, 8, 9, 10. 11. 11. But 11 in mode 5 is 1. So this is plus and minus 1. So the second point is 2, comma, plus and minus 1.